Real numbers can be broken down into different subsets, and the subsets would be rationals, irrationals, integers, wholes, and natural numbers. Now, each of these subsets can be represented by a letter. For example, real numbers is a cursive R, and the others are listed below. If you look at these in the Venn diagram, you can see that real numbers contain all of the numbers here. And starting with rationals, rationals can be written as a ratio, rational ratio, and irrational, they cannot be written as ratios, such as square root of 2 and pi. Within the rationals, you have the integers as written as 0, plus or minus 1, plus or minus 2, whole numbers, and natural numbers. The only difference between whole numbers and naturals is that whole numbers contain 0. Now, when you want to represent the numbers as an answer, we can do so by writing it as set builder notation or interval notation. Now, set builder notation is where you have a variable, and the variable would be written first, so it's all x's such that that's a colon, something like an inequality, and where x is an element. This is a element of a certain subset, such as any of these letters. And we'll do some examples in a little bit. Other way of representing numbers is by interval notation. You have to know that in a parenthesis, the number is not included on the end, and in a bracket, it is included in the end. So if you had, for example, something like this, where it is going from -8 to 0, what that means is that this parentheses means -8 is not included, and it's going to be all real numbers going to 0, which is included. And one thing to note here is that you are working within all real numbers when you use interval notation. Important to know. Then I'd like to do some examples on working with either set builder notation or interval notation. Some it's easier to write than others. This one, because it's not all real numbers, it has to be written as set builder notation. So for example, here you're going to have all x's such that x is greater than or equal to 17, where x is an element of all integers. Or you could even have whole numbers or natural numbers here. On this one, where you're talking about real numbers, you can use interval notation. And so you would see that you're going from a negative infinity. All x is less than or equal to -2. It's going to go out to negative infinity, which means that you're going to start with negative infinity. Now, notice that you always use a parenthesis with infinity because it can never be included. Infinity is not a number, it is a concept. So you're going from negative infinity and you're going to -2, and you are including -2, so you're going to have a bracket. You could do it in this fashion as well. It's just when you can use interval notation, it's probably easier to use interval notation, such as number 3. All x is greater than, not including -8.8, means that you have to have a parenthesis, and then it's going to be -8.8 going to positive infinity, and as you remember, you cannot have a bracket on positive infinity because it is never going to be included. Here are all real numbers between the two. This is easy enough to write on interval notation, not including 5, not including 15, but all the numbers in between. That concludes, we got a couple more. Maybe just a little bit more example using the set builder notation. Let's go to number 6. Number 6 is all numbers. Okay, so we're going to say it's all x's such that all x's such that x is going to be going to 7 from negative infinity. So we can say going to negative infinity and less than or equal to negative 7, where x is an element of integers. So that's going to be a z. Sorry about my handwriting there. And then that's going to be in set builder notation. Again, notice that because it's integer values, you cannot use the interval notation. Interval notation only is for real numbers. You don't see all real numbers here. You have to use the set builder notation. That concludes the lesson on the number systems or the subsets of real numbers, as well as two ways of representing numbers, set builder notation and interval notation.